Now that we learned about some important basics of React, most importantly about components and props, it's time to take the next step. And in this course section, we're going to take a closer look at user interaction and handling user events like clicks or input into text fields and so on. And we're going to have a look at the very important concept of state in React apps. Because you might remember that I mentioned earlier in the course that with React we follow that declarative approach where we in the end define desired target states and React then takes care about reaching that state. Well, that is correct and that is already something we're using, but at the moment in the application we built thus far and with the knowledge we gained up to this point, we can only build static applications where the state never changes, where we always output exactly the same. And that's typically not what you want. You want to have applications which are interactive so that you can react to clicks by the user and to data being entered by the user, and which are reactive so that the application also changes when certain things happen. And therefore, in this course module, we are going to take a look at handling events, handling user events like clicks and so on. And we'll see how that works in React apps, how we can add such event handlers and more. And then we're going to take a look at how we can ensure that what's visible on the screen changes, that we reach a different target state. And for that, we're going to take a closer look at this state concept in React, and we'll learn how we can manipulate the state and transition from state A to state B if we want to. And in general, in this section, we're going to learn about a couple of key concepts. This is a section you absolutely should not skip. And we're also going to take a closer look at components and state again. So this is another fundamental section covering core features of React. So let's dive in. So this is our demo application at the moment. And of course, it's fairly static. We have this output here on the screen, and we reach that output with help of our components, but as I mentioned, this never changes. It's static. We only have one state in this application, and that's this initial state which we see here. Now let's dive into how we can react to user events before we then have a look at how such events could trigger a state change. And when we want to start with events, I want to start fairly simple. I want to start with clicks on a button to which we want to react. And to get started with all of that, I'll go to the expense item where we output the title, the amount, and so on. And in there, I will also add a button below that div right before we close the card. And there, I will just say change title. And if we now save that, we will see this button here. Now, the styling is definitely not great, but this is also just a temporary button. We're going to remove it later. I'm just using it here so that we can start diving into events and state. Later, we'll use what we learned in better places, in places that really help our application. But for a start, we now have these buttons, one per expense item component. And my goal now is simple. When this button here is clicked, I want to change the title which is being output here. Initially, the title which is being output is the title we get via props. But I want to change it whenever this button is clicked. And therefore, we of course, first of all, need to find out how exactly we can react to button clicks in React. And it turns out that this is rather simple. On all built-in HTML elements like divs and h2, and especially also buttons and so on, we have full access to all these native DOM events which we can listen to. So if you search for HTML button element, for example, you'll find an article about this button. And there, if you click on the DOM interface here, this HTML button element, you see from which other elements or from which other classes this inherits in the end. And here you see that the HTML button element is a more specific form of the HTML element, which is a more specific form of the element, which is a more specific form of the node, and so on. And if we click on element, for example, we actually will see that there are a bunch of events to which we can listen. For example, click and blur. And basically for all these default events, there is a prop equivalent in React, which we can add to these built-in HTML elements to listen to these events. So instead of adding a listener as we would normally do it, by, for example, selecting an element by ID and then adding an event listener like this, which would be the imperative way of doing that, in React we add an event listener by going to the JSX element, like this button, and there we add a special prop. But now it's not a prop which sets some value for this button, but instead it's a prop which starts with on. Because React exposes all these default events as props which start with on. And for example, here we can add on click. Now what this does is it adds an event listener for click events to this button. Now we just need to define what should happen when such a click occurs. And we do that by assigning a value to this click event. And the value here, and that's now important, of course has to be code which should be executed when that click occurs. And how do we define code that should eventually be executed in programming? Well, we create a function. So all these on props, all these event handler props want a function as a value. A function passed as a value for onClick and all these other on props, which then is executed when that event occurs. Now here we can either create this function on the fly, for example like this. We can create an anonymous arrow function like this, and then here we could console log clicked if we wanted to. And if we save that and we go back and open the developer tools here in the browser, and there we go to the console part, if I click the title, we see clicked. So this is how that works. This is how simple it is to add an event listener to a React element. Now, typically you don't just want to work with such anonymous inline arrow functions though. By the way, it doesn't have to be an arrow function. You could also create a function with the function keyword. You don't want to overdo it, at least, because it would mean that you put a lot of code here into your JSX block, into your JSX code, and that's generally not a good idea. You want to keep that lean and not put too much logic into your JSX code. Instead, you typically want to define a function before you return, and you can do that either with the function keyword or again by creating a const or a variable which holds an arrow function. So here we could add a click handler const, the name is up to you, which holds an arrow function like this. And in there, I can also say clicked with a couple of exclamation marks. And then here for this button, we just point at click handler. And that's important, by the way. We just point at it. We don't execute it here. You don't add parentheses here. Instead, you just repeat the name of the function, no matter if you created that function like this or with the function keyword. This does not matter. No matter how you defined it, you just point at it like this. Why? Because if you would add parentheses here, JavaScript would execute this when this line of code is being parsed. And this line of code is being parsed when the JSX code is returned. So it's then not executing click handler when the click occurs, but when this JSX code is evaluated. And that would be too early. That's why instead we just point at the click handler, we just point at the function, we pass a pointer at this function as a value to onClick, and then React basically memorizes this and executes the function for us whenever the click occurs, so that it's not executed when this is evaluated, but when the click occurs, which is exactly what we want. So now when I save that and I reload here, you see now we have clicked with multiple exclamation marks, which is the console log from this const. And that is how we can add event listeners to our elements. To all these built-in HTML elements, we can add supported event listeners basically. On click, for example, basically is available on every element. Some events are only available on specific elements, but that is all based on the default DOM behavior. If an element supports an event, then you can add a listener with React by adding such a on and then the event name prop. Just make sure that the event name starts with a capital character, like in the case of onClick here. And then you just point at a function, either defined inline here or better defined up front, and React will execute that function for you when that event occurs. That's how you add events. Now, one word about naming these functions. It is a convention which you don't have to follow, but which you might consider following, that you name your functions like this if they are triggered upon an event, that you end with handler. This is not a must-do, and not every React developer does it, but it is a preference I personally have, and you will see it in a couple of projects out there, so that it's clear that this is a function which is not called by us somewhere else in our code, but that it is a function which we attach to an event listener so that it's eventually called by React when that event occurs. That's why I'm naming my event handler functions like this, ending with handler. But again, this is just my preference. You see it in a couple of projects. You might want to consider doing that, but you don't have to. But now with that, we know how we can react to events. How can we now change what is showing up on the screen though? Reacting to events is an important first step. How can we now change what shows up on the screen? Well, we want to change the title when the button is clicked. So here's one thing we could do. We could create a variable with let, which we maybe name title, and initially that holds the value we find in props title. And then we use this title variable down there in our JSX code to output the title. Now if I do that, we see the same result as before. So why am I doing that? Well, since it's a variable, we could change it whenever this click handler executes. So whenever this button is clicked, we execute this click handler function, and in there, if we now change title to updated, then we should see that changed title on our screen, right? Because we're outputting title down there, we're changing it up on a click, we should see that value here in this place after such a click happened. Well, let's save everything and give it a try. If we go back, you'll notice that if I click change title, nothing happens. I can hammer this button and nothing happens. This title here never changes. So why is this happening? Is something wrong with our click handler? Well, this function is getting triggered. I can prove this. If I console log the title here after we changed it, you will notice that if I now go back and reload, if I click change title, we see that updated title text here. So it looks like it worked, the click handler clearly executed, and title clearly was changed. Otherwise, we wouldn't see that new value, which we assign here in line 13, once we log it in line 14. So if the function executes and the title is changed, why don't we see that reflected in our DOM? After all, we are outputting the title down there in line 21. Well, simply because React doesn't work like this. And that's where I now have to dive into how React actually parses the JSX code and how it considers that and how it brings it onto the screen, though I will have an even deeper dive later in the course. But there's one key thing which you have to know right now. Keep in mind that your component is a function. This is a function, right? Your component is just a regular function. The only special thing about that function is that it returns JSX. Now, since it's a function, someone has to call it. And you might notice that we never called our component functions. Instead, we just use these functions like HTML elements in this JSX code. Well, the thing is, under the hood, this is almost like a function call. By using our components in JSX code, we make React aware of our component functions. For example, here, we make React aware of the expense item function. And whenever React evaluates this JSX code, it will call these component functions. And these component functions then return JSX code, which is also evaluated, up until there is no more JSX code to be evaluated. So React keeps on calling any component functions it encounters in JSX, then calls any functions that those functions might have returned, so any elements those components might have used in their JSX code, until there are no more functions left. So in the case of expenses.js, if React encounters this expense item, it calls this expense item component function, executes all the code in there, encounters this JSX code, and calls this card function and this expense date function. And then it goes through the JSX code of these components until there is no more component code left to call. And then it evaluates the overall result and translates that into DOM instructions, which renders something like this on the screen. That's how React works. Now it's all started by the index.js file, where we initially point at this app component. That's the first component function which is being called, and that happens when the React app is being loaded on the screen, which happens when the page is being visited. So that is how React goes through all these components, executes all these component functions, and draws something onto the screen. The only problem with that is that React never repeats that. React goes through all of that when the application is initially rendered, but thereafter it's done. However, in modern applications, of course, you sometimes want to update what's visible on the screen. For example, because a button was clicked and that button should change some text which is being output. So we need a way of telling React that something changed and that a certain component should be re-evaluated. And that's where React introduces a special concept called state. State is actually not a React-specific concept, but it is a key concept in React as well. And here in expense item, we have a scenario where we want to use that built-in state concept. Because this title here, which changes when the click handler executes, is actually data that should result in this component being re-evaluated and redrawn on the screen when it changes, when that title data changes. And by default, regular variables like this one are not triggering such a re-evaluation. React doesn't care about that. If you have a variable in your component function and that variable changes, React ignores it. It doesn't care about that. That code executes, sure, but the overall component function doesn't execute again just because some variable changed. And as a side note, even if it would execute again, of course then title, this variable, would also just be recreated and reinitialized to the props value, because as part of this component function, we are creating this title variable. So even if that would happen, we wouldn't reach the desired result, but we don't even need to think about that because it is not happening. This expense item component function currently is not called a second time after the initial rendering. Just because a click occurred or because a variable changed does not trigger this component function to run again. So to tell React that it should run it again, we need to import something from the React library. And we do this by adding a so-called named import. This here is the default import. Now we can add a comma and curly braces, and between the curly braces, we can now extract specifically named things from the React library. Here we import the overall React object. Now we want to import single pieces from the React library. And we want to import a function here, a function which is called useState. This is a function provided by the React library, and this function allows us to define values as state, where changes to these values should reflect in the component function being called again, which is a key difference to the regular variable we're using here. Now, how do we use this useState function though? Well, it's very simple. Inside of our component function, and that's important, we have to do that inside of this function, we just call useState. And useState is a so-called React hook. There are other hooks as well, and of course we are going to learn about all important hooks throughout this course, but that is one of the most important ones. And all these React hooks can be recognized by the fact that they start with the word use in their name, and all these hooks must only be called inside of React component functions, like expense item. They can't be called outside of these functions, like this, and they also shouldn't be called in any nested functions. They must be called directly inside such component functions. There is one exception, which I'll talk about later, but for the moment, that is what you should keep in mind. Now, useState doesn't work just like that. Instead, useState wants a default state value. Because with useState, we basically create a special kind of variable, you could say. A variable where changes will lead this component function to be called again. And of course, we can therefore assign an initial value for that special variable, just as we're assigning a value here for this regular variable. So here my initial value is props.title, and we simply pass this as an argument to useState. Now this special variable is created. Of course, we also want to be able to use that variable. We want to be able to use it down here, for example, and therefore useState also returns something. It gives us access to this special variable. However, it does not just return that. It also returns a function which we can then call to assign a new value to that variable. So we'll not be assigning values like this with the equal sign. Instead, we will be assigning new values by calling a function. That's just how this state variable thing works. And for that, useState actually returns an array, where the first value is the variable itself, you could say, the value itself, and the second element in the array is that updating function. And we can use a modern JavaScript feature called array destructuring, which looks like this, to store both elements in separate variables or constants. And here I'll use constants. And I'll come back to why it's a constant in a second. Now you can choose any names of your choice, because for array destructuring, it's just the order which matters. And I'll name this title and set title. The first element, as I just said, is a pointer at that managed value. So initially at props title, the value stored in props title. And the second element here is a function which we can later call to set a new title, hence this name which I chose. Both names are up to you, but the convention is to use something which describes the value as a name for this first element, since that is the value, and then set and then that name repeated, just with a capital starting character here, this capital T, for that function which updates the value. That's the convention on how you name these two elements returned by useState. And useState, this hook, always returns an array with exactly two elements. That's always the case, and it's always the case that the first element is the current state value, and the second element is a function for updating that. Now with that, we can remove that title variable, and we can also remove that value assignment in click handler. And we can still use title like this down there in JSX. So if we now save it like this, we still see toilet paper here. So that hasn't changed. But of course, the button still doesn't do anything because at the moment, we're never updating this. Now, as I said, with the value returned by useState, we're not going to assign a new value with an equal sign. Instead, we assign a new value by calling setTitle. So by calling this state updating function. And then we just pass the new value as an argument. In this case, updated. Now, why does it work like this though? Why do we have this state updating function instead of assigning a new value like this? The reason for that is that calling this function does not just assign a new value to some variable, but that instead this is a special variable to begin with. It's managed by React somewhere in memory, and when we call this state updating function, this special variable will not just receive a new value, but, and that's important, the component function in which you called this state updating function and in which you initialized your state with useState will be executed again. And that is exactly what we need. We want to call this component function again when our state changes. And by calling this state updating function, that's happening. Because by calling this function, you're telling React that you want to assign a new value to this state. And that then also tells React that the component in which this state was registered with useState should be re-evaluated. And therefore, React will go ahead and execute this component function again, and therefore also evaluate this JS Xcode again. And then it will draw any changes which it detects compared to the last time it evaluated this onto the screen. So if we now save everything, if I click change title, you see the title changes to updated for the expense item in which we're doing this. And that's now how this works. Now you will notice that these console logs still show the title before it was updated. The reason for this is that calling this state updating function actually doesn't change the value right away, but instead schedules this state update. So in the very next line thereafter, this new value isn't available yet. That's why we see the old value being logged even though we updated it before logging. But you do see that eventually this component is called again and is evaluated again, and that therefore we see our updated value on the screen. That's how React State works, and this is another key concept in React. If you have data which might change, and where changes to that data should be reflected on the user interface, then you need state. Because regular variables will not do the trick. With state, however, you can set and change values, and when they do change, React will re-evaluate the component in which the state was registered. And only that component, by the way, not any other components, just this component in which this state was registered. Now let's take a closer look at this state and why we use const and how this all works in detail. So now we learned about state, and state, as you can probably tell by now, is a key concept in React. Now there are a couple of things I want to clarify about useState and about why we use a const here, for example. Now first let's start with one important thing which I did mention in the last lecture already. useState registers some state, so some value as a state, for the component in which it is being called. And I want to be even more precise here. It registers it for a specific component instance. For example, expense item here is being used 4 times, right? In expenses.js, we have 4 expense items. Now, every item receives its own separate state, which is detached from the other states. We have one expense item definition here, but then this function is basically called 4 times when we create 4 expense items. And every time it's called, a new separate state is created. Of course, in the same way, but managed independently by React. So if we change the title in the first expense item, the other ones are not affected because they have their own state. That's really important. It's on a per component instance basis. So we have separate states even if we create a component more than once. And that's of course crucial because it would be a rather undesired behavior if we change something in one item and all the other items are updated as well. So that's a good thing to have. Now, in addition, whenever state changes, because we click a button in this case, it's only this component function and only that specific instance where this component is being used where React will re-evaluate it. And you can tell that this is the fact if you add another console log here in the component function itself, where you say expense item evaluated by React. This will be called whenever the expense item component function is being executed. And therefore, if I reload, we see it's called 4 times, which makes a lot of sense because we're using expense item 4 times in expenses. So 4 separate instances of this component are being created. But if I now click on change title in one of the expense items, we see it's only printed once, which is basically happening because of what I just explained. Only that specific instance is being updated and therefore being re-evaluated, and the other instances are not affected by that state change. And that's important to keep in mind, that state really is separated on a per component instance basis. Now there's one other thing which could be confusing, and that's the fact that I'm using const here. Why am I using const here when we do eventually assign a new value? Well, keep in mind that we're not assigning a value with the equal sign. That would indeed fail, but that is not how we assign a new value when we update a state. Instead, we call this state updating function, and the concrete value is simply managed somewhere else by React. By calling useState, we tell React that it should manage some value for us. We never see that variable itself. So therefore, we just call a function and we never assign a new value to title with the equal operator. And therefore, using a const is absolutely fine. How do we get the latest title value then though? Well, keep in mind that the component function is re-executed when the state is updated, and therefore, of course, this line of code, line 9, also is executed again whenever the component function is executed again. So if we call setTitle and we assign a new title, that leads to this component being called again, and therefore this new title, this updated title, is fetched from React, which manages this state for us. Basically, we go to React and say, hey, please give me that latest title state which I told you to manage for me. And React provides us this latest state in this array, which useState always returns. So we always get a brand new snapshot of that state when this component function re-executes. That's how this works under the hood. Now you might be wondering if that doesn't mean that we always overwrite any state changes with props title again here. And here the special thing is that React keeps track of when we call useState in a given component instance for the first time. And when we call it for the first time ever, it'll take that argument as an initial value. But if a component is then re-executed because of such a state change, for example, React will not re-initialize the state. Instead, it will detect that this state had been initialized in the past, and it will just grab the latest state, which is based on some state update, for example, and give us that state instead. So this initial value is really only considered when this component function is being executed for the first time for a given component instance. And I know that this is a lot of knowledge about state, and it might be confusing to a certain extent. It is just important to understand how state works under the hood, because if you don't fully understand that, then you will run into problems in more complex React applications where suddenly some value isn't updated as you expected it to be. That's why I'm explaining this in great detail. In a nutshell, using state is simple though. You just register state with useState. You always get back two values, the value itself and the updating function. You call the updating function whenever the state should change. And you use that first element whenever you want to use the state value, like here, for outputting it in the JSX code. And React will do the rest, and it will re-execute the component function and re-evaluate the JSX code, therefore, whenever the state changes. That's state, and that's an important concept, because it's state which adds reactivity to our application. Without state, our user interface would never change. But with state, and with listening to events, we can make sure that we can react to user input and that such input can result in a visible change on our screen. So state is a super important concept, and of course being able to listen to user events is also important, as you can tell.